Hello everyone! In this lesson, we will present to you the different formulas
and how to solve for the lateral area,
the total surface area,
and the volume of different solid figures.
So we hope that you've learned something from the discussion.
So sit back, relax,
and enjoy watching!
Bubbly, bubbly. Bubbly, bubbly. Set it! You see that girl with the big tic tac, she fi gimme the head to the floor, girl, gimme the bend over, girl, and gimme the spit down to the ground, seismic activity. Spin round me, girl, and gimme the top wine, girl, and gimme the body look fine, girl, gimme the coming out waste some time, girl, gimme the body look good, girl, you ever be winning it. Turn it up right, girl, you never be dimming it. Shake up your body, cause you're in your element. Funny body may take up a permanent residence. Rotate your body, come in over, you're spinning it. Rotate your body, come in over, you're spinning it. Rotate your body, come in over, you're spinning it. Make the trumpets blow.
Bubbly, bubbly. My name is Carol, and today I'm going to discuss to you how to solve a cube. So first, let us define what is a cube. So a cube is a special type of prism whose faces and edges are all congruent. Its length, width, and height are all equal. Thus, a cube is a regular hexagon. So after defining what is a cube, it is important for us to know what are the formulas that we are going to use in solving a cube. First is the diagonal length of the cube. So a cube is a regular solid in 6 equal faces. So first phase, second phase, third phase, fourth phase, fifth phase, sixth phase. So the length of the diagonal of a cube can be determined using the formula in finding the length of the diagonal of the regular solid, where length equals width equals height. Thus, if you let the s or the side be the length of one edge of a cube, then d equals square root of s squared plus s squared plus s squared, or simply d equals square root of 3s. So, after defining the diagonal of the length of the cube, now let us proceed to the surface area of the cube. So, the surface area of the cube can be found using the formulas of regular solid where side equals length equals width equals height. Thus, we will get the following formulas. So, for lateral surface area, we are going to multiply it by 4. So the side we will go to multiply it by 4 because we have 4 faces. So it is 4s squared. So for the total surface area, since we are talking about the entire or the totality of measurement of the figure or the totality surface of the figure, so we were going to have 6s squared because we have 6 equal faces. So in finding the volume, since the dimension, length, width, and height are all equal, the formula is volume equals s cubed. After defining and familiarizing all the formulas in solving a cube, now we'll decide an example. So we are asked to find the lateral surface, the total surface area, and the volume of a cube whose size is 16 centimeters. So we are going to use the formula for lateral surface area, which is 4s cubed. So simply, we will substitute the value of our side, which is 16. So 4 times 16 squared equals 256. 16 squared equals 256. So 256 times 4 equals 1024 centimeters squared. So be sure to put the label or the unit measure of our result. So next is for the total surface area. Total surface area equals 6 square. So, 16 square is 256. 256 times 3 equals 1,536 centimeter square. So, are we done yet? Not yet, because we will still have to find its volume. So volume, so the formula for volume is volume equals S cubed. So substitute the volume of our S, 16 cubed equals 4,096 cubic centimeter. So that's all. We are done on getting the values of our lateral surface area, the total surface area, and the volumes. So I hope you've learned something from our discussion for today, and I wish you well, guys.
Hi guys, my name is Melvin, and today I'm going to show you how to solve for the total surface area and volume of a pyramid. But first, let us define what's a pyramid. A pyramid is a polyhedral with triangular lateral faces, whose vertices meet at common point, called the vertex, or sometimes called the apex, the highest point of the pyramid. There's also a regular shaped polygon base that determines the type of the pyramid. In this case, this is a square pyramid, since the polygon base is a square. Other type of pyramid may be called triangular pyramid, hexagonal pyramid, and so on and so forth. Now, the highest point of the pyramid is called the apex, or simply the vertex. This is the base. And the triangular lateral faces called as the lateral face. The perpendicular distance from the vertex until the base of the pyramid is called the axis of the pyramid, which determines the height or the altitude of the pyramid. The point where the lateral faces meet is called the lateral edge. The distance between the center of the polygon base to the perpendicular side, we call this as an apotheta. The height of the triangular lateral face, we call it as slack height.
Now let's try to solve an example. Here's the problem. A regular hexagon pyramid has one lateral edge which measures 10 cm. The length of one side of its base is 6 cm. Find the altitude and slant height of the given pyramid. Also find the volume and the total surface area. In the problem, we are asked to find the height, the slant height, the volume, and the total surface area of the pyramid, given the lateral edge, which measures 10 cm, and the measure of one of the side of the base, which is 6 cm. In order to find the height, the length, the slant height, the volume, and the total surface area of the pyramid, first we have to find the altitude of the pyramid. Now let us consider the base. Since this is a regular hexagonal pyramid, we assume that the base is also a regular hexagonal polygon. Therefore, we all know that the measure of the angle inside the polygon is 360 degrees. If we are going to divide the hexagon in equal parts, we will be able to get 6 equilateral triangles, meaning that the triangles have equal
internal angles and equal sides. Here, as you can see, since we have 6 equilateral triangle here, the 360 degrees we will divide it by 6 so that we will be able to get the angle of one of the triangles, which is 60 degrees. Okay. Now, assuming that one of the triangles here measures 60 degrees, let's try to divide the triangle so that one of the angles would be 30 degrees, and here is the apotem, as you can see here. This is the triangle inside the hexagon, and we're trying to find the value of the apotem. The apotem is the perpendicular distance from the center of the polygon perpendicular to one of the sides of the base. Now, since we knew the value of one of the sides of the polygon is centimeter, assuming that this is a regular polygon, meaning that the sides, assuming that these are all equilateral triangle, so we assume that this is also 6 centimeter, 6 centimeter, 6 centimeter, and so on and so forth. Then, since we take the half of one of the triangle, see, we will also divide 6 centimeter by 2. So that you can get the value of the side here. So this would be 3 centimeter. Now that we know the internal angle of the triangle, one of the angles of the triangle, we also have the value of the value for the one of the side, and we are looking for the value of the apotem. We may use the formula tangent theta is equals to opposite divided by adjacent side. Here, we have 30 degrees, so that's 30 degrees, tangent 30 degrees is equals to the opposite, which is 3 centimeter, all over A. Supposing this, we'll be able to find the value of A by 3 centimeter, all over tangent 30 degrees. Now, if you're going to solve this using your calculator, you'll be able to find to get 5.2 centimeter. So that would be the value of the apotem. Here, the distance here. So there. Now that we have found the value of the apotem, the next thing we need to do is to find the value of the side here. So let us mark this as side x. Okay, let's try to redraw the triangle here. So this is the value A, and we have 3 centimeter here. We have 30 degrees here, and we mark this as x. We can use the sine formula. Sine theta is equals to opposite over the hypotenuse, or sine 30 degrees is equals to the opposite, 3 centimeter, all over the hypotenuse. We mark it as x. So transposing this to find x is equals to 3 centimeter all over sine 30 degrees. Now, if we're going to calculate this in your calculator, we will be able to get 6 centimeter. So that will be 3 centimeter divided by sine 30 degrees. 10 degrees is 0.5. So we get 6 centimeter. Okay, now that we have found the value of the side here and here, so this side and this side, we can now find the value of the height. Okay, we're going to redraw this triangle here from the apex to the center of the base and to the one of the lateral edge there. Let's try to redraw the triangle. This is the height, this is the lateral edge, and we find this value, letter x, there. Mark. Okay, that's x, this is h,
the lateral edge, which is equals to 10 centimeter, and our x is equals to 6. Now, to find the value of h, we can use the Pythagorean formula, which is c squared is equals to a squared plus b squared. Now, since the hypotenuse denotes letter E, A, side A, is side B, we can rewrite the formula here, or from the Pythagorean theorem, we can simply write h is equals to square root of b squared minus x squared. Now, we're going to substitute the value. E is equals to 10 centimeter squared minus the value of x, which is 6 centimeter squared. Performing the operation, we will get square root of 100 centimeter minus 36 centimeter. That will give us the square root of 64 centimeter. So the value of h, or the height of the pyramid, would be 8 centimeter. Now we have found the value of the height. So from the apex into the center of the polygon, the base, that's the height of our pyramid, which is 8 centimeter. Now let's try to find the slope for the slant height. The slant height is the distance from the apex or the vertex of one of the lateral face into the center of one of the sides of that lateral face. So we're going to redraw triangular face there, one of the lateral face. This we knew, we already have the value for the apotem there, the apotem. So if this is the lateral face, our height would be, for example, at this point. And then we have the apotem here. So we have made the triangle there. So we can be able to make another triangle inside here. So that's from here and to here. Okay. So if that's the triangle, so again, this is the height, this is the apotem, and we are looking for the slant height. The slant height here. Now in solving for the value of slant height here, we can also use the Pythagorean theorem, which is c squared is equals to a squared plus b squared. Then we will try to replace that formula by substituting the letter here. So this is our hypotenuse. So our formula for the slant height would be slant height equals to the square root of the height plus the square of the apotem. That would be, substituting the value of 8 squared plus 5.2 squared is equals to the square root of 64 plus 27.04. We're going to perform this, you'll be able to get 9.54 centimeter. Okay, and that will be our slant height. Slant height here from this center of the base, the side of the base, until the apex or the vertex of this lateral face. So our slant height will be 9.54 centimeter. Now that we have calculated the value of the height and the slant height, what we are going to do next is to find the value of the volume and the total surface area. To find the volume, we make use of the formula and finding the volume of the pyramid, which is volume is equals to 1/3 of the base area times the height. Now the problem is, we haven't calculated yet for the base area, so we need to find the base area, or the area of the base. Now, if we try to redraw, or try to analyze again the base of the hexagonal pyramid, as we have the discussed earlier, we have a triangle here, that the hexagon has been divided into 6 equilateral triangles, that this side here is our apotem, which the value is 5.2 centimeter. Now, the base area, since this is our triangle, okay, the base area of the triangle is 1/2 BH. But in this case, the height of this triangle, we are referring to the apotem. So we can replace H here as A. Okay. But since there are n numbers of triangle here, okay, there are 6 numbers actually, but there are n number of triangles here. So we have to multiply this area by n number of triangles. Because this formula is for one triangle only, so we're going to calculate the base of this full hexagon. We have to consider all the triangles. So we have to multiply that by n numbers of triangles. Okay. Now, if we're going to simplify this, we try to distribute n. We're going to get 1/2 NBA. But here, you'll notice that NB, the number of sides here, the number of sides of the polygon here, and the height of the base, when we multiply that, the base, the number of the base times the volume here, and multiply by the number of the sides, we are referring to the perimeter of this hexagon. So perimeter is equals to NB. So we will replace NB by 1/2 P, which equals to the product of the number of the sides of the polygon and the measure of one of the base, and multiply it by the apotem. So the base, the formula for finding the base of the pyramid, the base area is equals to 1/2 times the perimeter and the apotem. Okay. Now let's try to solve by substituting the value. So our B would be 1/2 P, which is, there are 6 numbers inside here. 6 multiplied by, we already have measures here. This is 6 centimeter. Then we have to multiply it by 6. And then the value of the apotem is 5.2 centimeter. So that would be 1/2 times 36. 36 divided by 2. That would be 18. Times 5.2 centimeter. So the value of the base would be 93.6 centimeter square. Now, can we find the volume now? Yes, we already have the volume for the base. So let's try to substitute. The volume of the pyramid would be 1/3 times the base, which is 93.6 centimeter, times the height of the pyramid, which is 8 centimeter. Now, performing the operation, we will get 249.6 cubic centimeter, and that's the volume. It's 249.6 cubic centimeter. Now, in finding the total surface area of the pyramid, we will make use of the formula base area plus the lateral surface area. Okay, that's the base area. We have already calculated the base area here, which the value is 93.6 centimeter. Then, all we have to find is the value of the LSA, or the lateral surface area. Okay. LSA is equals to 1/2 times the perimeter times the slant height of the pyramid. Perimeter refers to the number of the sides here, multiplied by the volume, one of the sides of the base. So that would be 1/2 times, so we have 6 lateral, we have 6 triangular lateral face there. multiply that for the value of the side. So the side is 6 centimeter. And then again multiply that with the value of the slant height, which is we already calculated that, so that's 9.54 centimeter. We're going to perform this operation to get the value of LSA. LSA is 171.7 square centimeter. Now, TSA would be substituting the value of the base area plus the lateral surface area. So that's 93.6 centimeters square plus 171.7 centimeters square. So our TSA would be 265.3 centimeters square. And there you have it. Thank you.
Hi, I am Choi, and today I am going to discuss to you on how to solve the value of lateral surface, total surface area, and the volume of a cylinder. But first, let us define what is cylinder. Cylinder is a solid bounded by a closed cylindrical surface and two parallel planes cutting all the elements of the surface. Let's cite an example of a cylinder. This can is an example of a cylinder, since it has a parallel base and a curved surface. Let's now identify the parts of the cylinder. These two parallel planes are called the bases of the cylinder. This cylindrical surface or the curved surface is called the lateral face. And the distance between two bases is called the altitude or the height of the cylinder. So now let's identify the formula of surface area, lateral area, and the volume of the cylinder. To get the formula of surface area, we need to derive first the formula by observing the cylinder. In order to get the volume of surface area of a cylinder, we need to derive first the formula of a surface area by observing the figure. The surface area of a cylinder is composed of two circular bases and lateral face of the cylinder. So since we have two bases, we need to find the area of a circle. With the use of this formula, area is equal to pi r squared. Since we have two bases, we have 2 pi r squared. For the lateral faces, so try to cut the cylindrical surface through the points of the circumference of the base, then spread it out. So then it will look like a rectangle whose length is equal to the base of the circumference, then the height of a cylinder, which is 2 pi r times the height of the cylinder. Next, the lateral area, which is 2 pi rh, which is 2 pi rh is the circumference of the base times the height of a cylinder. Next, we have the volume equals to base times height, where b is equals to pi r squared times the height. So let's cite an example using the formula of surface area. Let's cite an example using the formula of SA, which is surface area. We have 2 pi r squared plus 2 pi rh. Let's say we have the value of r, or the radius, which is 3 centimeter. H is equals to 4 centimeter. Okay, in order to find the surface area, we need to find first the given. So what are the given? The r, or the radius, is equals to 3 centimeter, What's the height? Height is equals to 4 centimeters. We can now use the formula of surface area, which is 2 pi r squared plus 2 pi rh. Substitute 2 pi times the radius, which is 3 centimeters, plus 2 pi times the radius, which is 3 centimeters, times the height, which is 4 centimeters. Simplify. 2 pi 3 centimeters raised to 2 is equals to 9 centimeters squared. Plus 3 centimeters times 4 centimeters is equals to 12 centimeters squared. 2 pi times 9 centimeters squared is equals to 18 pi centimeters squared. Plus 2 pi times 12 centimeters squared is equals to 24 centimeters squared. Then combine or add them. So we have 42 pi centimeters squared. So our surface area in this cylinder is 42 pi centimeters squared. Next, we have the lateral area, which is, in order to get the volume of lateral area, we have 2 pi rh. So, according to given, the radius is 3 and the height is 4 centimeters. Our R is 3 centimeters and the height is 4 centimeters. 3 centimeters times 4 centimeters is equals to 12 centimeters squared. Then we have the simplify and we can now get the volume of lateral area, which is 24 pi centimeters squared. Lastly, the volume of the cylinder, which is V is equals to base times height, where B is equals to pi r squared h. So let's derive the given. R, which is 3 centimeters squared, times 4 centimeters squared. Centimeter, rather. 3 centimeters squared is equals to 9 centimeters squared times 4 centimeters. 9 centimeters squared times 4 centimeters is equals to 36 pi cubic centimeter. Now we have already our volume, the lateral area, and the surface, which is surface is equals to 42 centimeters squared. The lateral area is equals to 24 pi centimeters squared. And lastly, the volume, we have 36 pi cubic centimeter. Thank you.
Hello guys, I'm Josh. Today, I will discuss to you the surface area and the volume of a cone. First, let's define cone in its parts. I have here an example of a cone whose base is a circle called right circular cone. A three-dimensional shape that tapers smoothly from a flat base to a point called vertex. And this part called the lateral surface. And this circle called the base of the cone. A line segment joining from a vertex to a center of the base called the height. And this line called the radius. And this part from a vertex to the circumference of the base is called the slant height. Note, the height, radius, and the slant height can be formed a right triangle. Thus, the given values of any two of these measurements, the third value can be found in Pythagorean theorem. The equation is L squared is equal to R squared plus I squared. The formula of total surface area is equal to the lateral surface area plus the area of the circle. Since we all know that the area of the circle is equal to pi r squared, where r is the radius. In finding the lateral surface area, we must unroll the cone and it will form a sector. Since the area of the sector is equal to 1/2 times r times s, where r is the radius and the s is an arc of length. By using this formula, change the radius to the slant height and the s to the circumference of the circular base. So let r is equal to the slant height and the s is equal to circumference is 2 pi r. So the lateral surface area is equal to 1/2 times the slant height times 2 pi r. Simplify, so we have pi r l. So we have a lateral surface area. Hence, the total surface area is equal to pi rl plus pi r squared. Or simply, pi r times the quantity of L plus R. So we have the total surface area. In the volume of a cone, right or oblique follows from the general formula for the volume of a pyramid, which is V is equal to 1/3 base times height. Since the base of the cone is circle, we use the area of the circle. So, B is equal to the area of the circle is pi r squared. So, we have the value of B. So, substitute the value of B. So, we have the volume of a cone is equal to 1/3 pi r squared times height. So, we have the volume of a cone. After we define the surface area and the volume of a cone, let's cite an example. I have here in a figure with a given of height is equal to 25 cm and the diameter is equal to 20 cm. So, we need to find the total surface area and the volume of a cone. Since we don't have a radius and the slant height, we need to find first them. So, R and the slant height. Since radius is the half of the diameter, R is equal to 1/2 D. With a given of D is equal to 20 cm, substitute the value, which is 1/2 times 20 cm. So 1/2 times 20 cm is equal to 10 cm. So we have the radius. So in slant height, since the cone has a right angle, so we use Pythagorean theorem. The formula is L squared is equal to R squared plus H squared. So we have the height and the radius. So substitute them, we have 10 cm squared plus 25 cm squared. So we have 100 cm squared plus 625 square centimeter. So L squared is is equal to, the sum is 725 square centimeter. Now, extract the roots. We have L is equal to 26.93 centimeter. So we have the slant height. So we have the value of radius and slant height. So we now solve the total surface area. So the formula of total surface area is equal to pi or times the quantity of slant height plus radius. So we have the value of radius and slant height. We need to substitute them. So pi times 10 centimeter times the quantity of 26.93 centimeter plus 10 centimeter. So find the sum. We have pi times 10 centimeter times 26.93 centimeter plus 10 centimeter equals 36.93 centimeter. So find the product. So we have pi times 369.30 square centimeter or 369.35 square centimeter. So we have total surface area. Let's go now to the volume of a cone. So the formula of volume is 1/3 pi r squared times height. So we have given of height is equal to 25 centimeter and the radius is 10 centimeter. Substitute them. So we have 1/3 times pi. Substitute the radius is 10 centimeter squared times 25 centimeter. So 10 squared is equal to 100 square centimeter times 25 centimeter. 100 times 25 is equal to 2,500 cubic centimeter. So 1/3 times 2,500 square centimeter, we have volume is equal to 833.335 cubic centimeter. So we have the volume. So that's it. Thank you.
Hi, I'm Darwin. As we continue our discussion, I have here another example of solid figure, and this is what we call a sphere. From the previous discussion, they got the area of the lateral faces, surface area, and the volume of solid figures. But because a sphere has no lateral face, as you observe, okay, we will discuss and focus on getting its surface area and volume. But before we start, let me first define sphere. A sphere is a solid which could be associated to the picture of a globe or a perfectly round ball. This solid is bounded by a closed surface called spherical. All points of which are equal distance from fixed point within called the center. Okay. Now, let's go to the formula of the area of a sphere. The surface area of a sphere is equal to the product of the diameter and circumference. S is equal to BC. Then, the surface area of a sphere is also equal to 4 times the area of its great circle. How? Let's do this. S is equal to BC is equal to 2r times the circumference is 2 pi r, which is equal to 4 pi r squared. Is equal to 4 the area of great circle. form another sphere, we will add 0.2 to D and the result will be 1.2D. This is the increased sphere. Then we have the diameter. It is increased by 0.2, so it will result to 1.2D. From the original formula of the surface area of the sphere, that is surface area is equal to 4 pi r squared is equal to 4 pi. The radius, take note that the radius is 2 radius is equal to diameter, or vice versa. 1/2 diameter is equal to the radius. So p over 2 squared. We have a new formula for that. Then, but because the given is only diameter instead of radius, we convert the radius of the original formula of the area of the surface area of the second sphere. That results to 4 pi times d over 2 squared. Now, in order to solve for this, we will substitute the given, which is 1.2d. So surface area is 4 pi times what is diameter? 1.2 diameter over 2 squared. Okay, which result to 1.44 pi d squared is equal to pi d squared plus 0.44 pi d squared. The volume of a sphere is equal to 4/3 of pi multiplied to radius raised to 3. Volume of a sphere is equal to 4/3 times pi radius raised to 3. Okay. For example, if the given radius is 6 cm, how can we solve this volume? Given its radius is equal to 6 cm, we must substitute the given 6 cm to the original formula of a volume sphere. V sub S is equal to 4/3 times pi times 6 cm raised to 3. The result would be 904.78 centimeter, cubic centimeter. Okay, that will be our volume. Okay. What if the given is the diameter of a sphere? For example, D is equal to 24 centimeters. Okay. What will you do to get the volume of a sphere? From the original formula, we have Ds is equal to 4/3 pi r cubed. Okay. V sub S is equal to 4/3 pi. We now convert the radius to diameter so that we can substitute the given from this. Okay, it will be b over 2 raised to 3. Okay, we can now substitute the given. V sub S is equal to 4/3 pi T is 24 centimeter over 2 raised to 3. It will result to 4 over 3 pi 24 raised to 3 centimeter raised to 3 over 2 raised to 3. We have 4 third pi quantitative 13824 centimeter raised to 3 over 8. Cancel out this and we have 1 over 6 pi times 13,824 centimeter raised to 3. By solving this, we have 2304 cubic centimeter, which is the volume of a sphere. Okay. You have the final answer here. 2,304 centimeter cube.
Hi everyone, I'm Ryan. Now that you guys are familiar with different solid figures and how to solve for their areas and volumes, do you ever wonder how these solid figures will combine together? For example, a cone and a cylinder. If they are combined together, it will never be a cone or a cylinder alone, but instead, this will be called as composite solids. Composite solid is a combination of two or more solid figures. And now, our topic is solving the volumes and surface areas of composite solids. Let's cite an example. In the problem, a solid figure consists of a cone, a cylinder, and a hemisphere, which is the half of the sphere. Here as prime for its surface area and the volume. But let us find the first surface area. In the first figure, no, the first one is the radius, which is 4 centimeters. The slant height, which is said to be 3 times the radius. It will be equal to 12 centimeters. The height of the cylinder, which is 4 times the radius, which will be equal to 16 centimeters. And the height of the hemisphere, which is equal to 1/4 the height of the cylinder. So, the radius is equal to 4 centimeters, the slant height is 12 centimeters, the height of the cylinder is 16 centimeters, and the height of the hemisphere is 4 centimeters. The next thing to do is to solve for the surface area of the solid independently. So let's solve first for the surface area of the cone. Surface area of the cone is equal to pi r multiplied by radius plus the slant height. Then substitute within pi r is equal to 4 centimeters multiplied by 4 plus the slant height is equal to 12 centimeters.
To the floor, girl, gimme the
Then
bend over,
simplify.
girl, and gimme the straight down to the ground, seismic activity. Spin round me, girl, and gimme the top wine, girl, and gimme the body look fine, girl, gimme
So the surface area of the cone is equal to 65 centimeters squared.
never be winning it.
Then let's solve for the surface area of the
Take up your
cylinder.
body, cause you're in your element.
Surface area of the cylinder is equal to 2 pi r multiplied by 1. Wait. Copy the 2 pi Then substitute the given in the formula. The area is equal to 4 centimeters. Height of the cylinder is equal to 16 plus 2 pi times the radius 4 squared. Then simplify.
Make the trumpets blow.
So the surface area of the cylinder is equal to 163 pi centimeters
Man,
squared.
don't stop watch when you bubbly, bubbly. Serious thing, it and a comedy,
We
comedy.
have the
And them
surface
say,
area for
comedy,
the
comedy.
hole
Some me
in the
want get some and
cylinder.
come
So
trouble, trouble.
let's solve the surface area of the
Calling
hemisphere.
two friend and then double, double. Girl, so hot, she a bubbly, bubbly.
The
And she know
surface
when she
area
got, she a
of
carry me remedy. And it look good, girl,
the sphere,
it
which is equal to
take up
4
your body, 'cause you're in
pi
the element.
r
Body,
squared.
body, me take up a permanent
Substitute
residence.
4 pi, the radius is equal to 4 squared. 4 pi,
Sounding trumpets. Rotate your body, come in over, you're
4
spinning
pi.
it. Rotate your body, come in over, you're spinning it. Rotate your body, come in over, you're spinning it.
Well, it's not yet an answer. Now that we have the surface area of the cylinder, the hole, and the hemisphere, in order to know the surface area of the figure, all we have to do is to add this surface area. Surface area of the hemisphere is equal to 32 pi centimeters squared. The surface area of the cylinder is equal to 165 centimeters squared. And the surface area of the cone is equal to 64 pi centimeters squared. Then, add.
Bubbly, bubbly. Bubbly, bubbly.
We have found the surface area of the composite solid. Now, let's find for its volume. In solving the volume of the composite solid, the process is just the same in solving for its surface area, wherein we should consider first what are the given in the problem.
Bubbly, bubbly.
So the given are the
You see that girl
radius
with
is
the
equal
big
to 4
tic tac, she fi gimme the,
centimeters. The
gimme
height of the
the.
cylinder,
Bend to the
which
floor,
is
girl,
8
gimme the, gimme the.
centimeters.
Bend
The
over,
slant
girl,
height
gimme the,
is
gimme the.
12
Spit down to
centimeters.
the ground, seismic activity.
Since we are looking for the volume
Girl,
of
and
the
gimme
figure,
the, gimme the.
the height of the
Girl,
hole
and gimme the, gimme the. Body look fine, girl, gimme the, gimme the. Coming out, waste some time, girl, gimme the,
is
gimme the.
equal to
Body
12
look good, girl, you
centimeters.
never be winning it. Turn it up right, girl, you never
Since
be
we
dimming
have
it.
it,
Take
let's
up your
solve
body, 'cause you're in your element.
for the
Body,
volume
body,
of
me
it,
take up a
or for
permanent
the volume
residence.
of the solid
Rotate your body, come
independently.
in over, you're spinning it. Rotate your body,
So
come
the
in
volume
over,
of the
you're spinning
hole
it. Rotate your body, come in over, you're spinning it. Make the
is
trumpets
equal to 1/3 pi r squared height. Prefix the 1/3 pi, then substitute. R is equal to 4 centimeters squared times the height of the cone, which is equal to 12 centimeters. Then simplify. So the volume of the cone is equal to 64 pi centimeter cubed. Then, solve for the volume of the cylinder. The formula is base times height or pi r squared height.
and them say you have the comedy, so me won't get someone come
Prefix the pi, then substitute the value of the radius and the height of the cylinder.
Girl so hot, she a bubbly, bubbly, and she know when she got, she a carry me remedy. And it look good, girl, you ever be winning it. Turn it up right, girl, you never be dimming it. Take up your body, 'cause you're in your element. Pon your body, me take up a permanent residence.
So the volume of the cylinder is 64 pi centimeter
Sound the
cubed.
trumpets.
Then let's solve for the volume of the sphere. The formula and then the formula of the sphere is 4/3 pi r cubed. Prefix the quarter pi, then substitute the value of the radius. The volume of the hemisphere is equal to 85 or 33 pi centimeter cube, but we will divide it into two since the given in the figure is a hemisphere. 85.33 divided by 2 is equal to 42.67 pi centimeter cube. So the volume of the cone is 64 pi centimeter cube, cylinder is 64 pi centimeter cube, and the volume of the sphere or the hemisphere is 42.67 pi centimeter cube. But it's not yet the volume of the solid figure, because in finding the volume of a composite solid, we must add the volume of each solid. Volume of the cone is the volume of the composite solid is equal to 117.675 centimeter cube.
Four over 3 pi r cubed gives you the volume of a sphere. But where does the formula come from? First, we'll draw a perfect sphere and fill in its volume. Next, we will divide the sphere into equal-sized pyramids with square bases. So let's take a look at one pyramid, and remember that its volume is equal to 1 over 3 area of the base times height. Now let's quickly show that the height of all the pyramids that make up the sphere is actually equal to the radius. So our equation becomes 1 over 3 area of the base times radius. And we will simplify this equation by replacing radius with r and area of the base with b. We will be numbering the bases, so we start with base 1, and our equation is base 1 r over 3. So in order to find the volume of the sphere, we simply have to calculate the volume of the pyramids and add them together, giving us a simple formula. So lining up the pyramids, we start from the beginning, and we have volume of the sphere is equal to base 1 r over 3 plus base 2 r over 3 plus base 3 r over 3. And we will continue this process up until the last pyramid. Now we don't know how many pyramids we have, so we just let base n r over 3 simply represent the last pyramid. So having added up the pyramids together, we have this complete simple formula to work with. So next, we will use algebra and begin by factoring out a 1 over 3, and we will also factor out the radius, giving us r over 3 times the sum of all bases. So now let's concentrate on the sum of all bases, and remember, these are the bases of the pyramids that make up the sphere. And as you can see, the bases actually form the surface area of the sphere. So the sum of all bases is equal to the surface area, which is equal to 4 pi r squared. Now, a quick explanation for why the surface area is 4 pi r squared is first we'll look at our sphere and take its largest possible circumference. With that circumference, we'll make a circle. And now the amazing fact is the surface area of the sphere is equal to exactly 4 times the area of the circle. The area of each circle is pi r squared. Combine them together and we get 4 pi r squared. So now let's go back to our simple formula and replace the sum of all bases with 4 pi r squared. Now we combine the r's together to get r cubed, and now we simply rearrange the equation to get 4 over 3 pi r cubed. So 4 over 3 pi r cubed gives you the volume of any size sphere that exists.
Turn it up right, girl, you never be dimming it. Take up your body, cause you're in your element. Pon your body, me take up a permanent residence. Sound the trumpets. Sound the trumpets. Rotate your body, come in over, you're spinning it. Rotate.